This is a summary of Project ER234022, Method to Measure PFAS in Mil-Spec AFFF by Extraction. I'm Paul Edmiston, Principal Investigator at the College of Worcester. This project is a response to the BAA 220025, Development of Analytical Methodologies for Determination of Total PFAS in PFAS-Free Firefighting Formulations. The technical objective of this work was to develop an extraction-based method to measure PFAS in fluorine-free foams called F3 concentrates at 1 part per billion or less. This is to meet the MIL PRF 32725 requirements that these fluorine-free foams be less than 1 part per billion PFAS. We evaluated both the HPLC mass spectrometry and organofluorine analysis as method analysis to make the PFAS measurements. Our overall goal was to develop a standard operating procedure that could be performed by commercial analytical labs, including QA and QC processes. Why is organofluorine extraction important? Well, F3 products are approximately 30% by weight polymers and surfactants. These are incompatible with instrumental methods like LCMS and organofluorine methods like combustion ion chromatography. Organofluorine is an interference for organofluorine measurements, so an extraction method to separate PFAS from inorganic fluorine is important. Also, extraction can provide pre-concentration, and that allows methods that have higher limits of detection than 1 part per billion, like combustion ion chromatography, to be used. Our extraction method is as follows. A sample of F3 is taken. Often this can be diluted 1 to 10 to improve the extraction process. At this stage, surrogates, which are isotopically labeled standards, can be added to the formulation for QA/QC control purposes. An absorbent is then added to the F3 mixture and shaken for 4 hours. The absorbent that we use then settles very quickly to the bottom of a centrifuge tube. And in that absorbent would be PFAS compounds that have been removed from the formulation. The residual formulation is decanted, typically through an empty solid phase extraction cartridge. The absorbent is rinsed to remove any residuals, and then the PFAS compounds are eluted with methanol with some ammonia. The methanolic solution at this point can be directly analyzed by LCMS to measure individual PFAS compounds. Our project has been successful at measuring PFOA and PFOS to below the 1 part per million detection limit using LCMS. In our experiment, we would spike F3 with these compounds at 2 to 1.5 ppb. We get accurate measurement of the concentration, appropriate signal to noise, and MDLs, which are method detection limits that are less than 1 part per billion. Thank you for listening to this summary.